All right, last chapter, we are talking about trig in this particular unit. And so we've got a couple things to go over. The first of which starts off with a review from geometry, which is the SOHCAHTOA acronym that we use to help us remember how to find some of the trig values. So SOHCAHTOA, remember, is telling you that sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. And then finally, tangent opposite over adjacent. So if you write out the whole acronym, that's what you would get. So what this is telling us is the sine of an angle is going to be opposite over hypotenuse. Cosine is the ratio of the adjacent side over the hypotenuse. And tangent is the ratio of the opposite side over the adjacent side. Now, in geometry, they don't typically go over the other three trig functions, which we call the reciprocal functions. The reason why they're called that is because each of them is the reciprocal of one of the originals. And I've lined them up underneath the ones that they go with. So the reciprocal function of sine is cosecant. If you want to spell the entire word, it looks like this. And so because it's the reciprocal of sine, we find it by doing hypotenuse over opposite. Secant, which would be spelled like this, is hypotenuse over adjacent because it's the reciprocal of cosine. And cotangent, spelled exactly like you would think it would be, is the ratio of the adjacent to the opposite because it is the reciprocal of tangent. So we'll need those when we're going to do some of the examples, finding one trig function either based on a value to solve a problem or finding one based on the other. Another thing that we have to review from geometry are the special right triangles, a 45, 45, 90 and a 30, 60, 90. So when you have a 45, 45, 90, that means it's an isosceles right triangle. So two equal sides, which means two equal angles, both at 45 degrees. In these, the hypotenuse is the leg times radical 2. Now, they're going to ask for some variation of sine, cosine, tangent, secant, cosecant, cotangent of these special right triangles. So they might ask you for the sine of 45 degrees or, the tangent of 60 degrees. When they do that, they're going to use the leg values as being 1 and the hypotenuse as being radical 2. So if we wanted to find, for instance, the sine of 45 degrees, we would do, because sine is opposite over hypotenuse, we'd start at a 45-degree angle. Opposite means across, so that'd be 1 over the hypotenuse, which is always across from the 90-degree angle, 1 over radical 2. And then we would rationalize, which we've already gone over in this course, to get radical 2 over 2. Similar idea in a 30, 60, 90. So this is 30 degrees, this is 90, and this is 60. Then we have hypotenuse equals short leg times 2, and long leg equals short leg times radical 3 is what we learned in geometry. So what they'll do in this section is make the side across from the 30-degree angle a 1, and that's the short leg. So if the short leg is 1, 1 times 2 would be the hypotenuse. 1 times radical 3 would be the long leg. And so then when I want to find a specific ratio, I would use these sides. So for instance, I could look and do the tangent of 30 degrees and say, okay, 30 degrees, that's going to be opposite over adjacent. So opposite is 1, adjacent would be radical 3, and then rationalize. So then I would know that the tangent of 30 degrees is radical 3 over 3. And that's just a couple examples. You could obviously do any of the trig functions once you have all those sides. All right, other examples. If the sine of theta is 5 over 12, find the values of the other trig functions. So when you have this, you really need to draw a picture and use these SOHCAHTOA issues. So I draw myself a random right triangle. It doesn't matter if it's to scale or not. That's not important. So wherever my theta is, let's say theta is here. This is my angle. So sine, if I go up and look, is opposite over hypotenuse. So the opposite side to this theta would be here. The hypotenuse would be here. So if these are my values, I can find the other 5 trig functions as long as I find the missing third side. Remember, the Pythagorean theorem that you learned in geometry tells you that in any right triangle, we're going to have the sum of the two sides equal to the sum of the square of the hypotenuse. So this is the side I don't know. So 5 squared plus x squared equals 12 squared. So this is 25. This is 144. So subtract 25 on both sides. And then those cancel out on the left side. So I'm just left with x squared on the left. Then on the right side, I end up with 119. So then to get x alone, I would square root both sides. So x equals the square root of 119. I go ahead and I label it. Obviously, if it were a perfect square, you would, simplify that. This one's not. And then we can find all 6 of the other trig functions. So I know for sure that cosecant is easy because it's the reciprocal of sine. So cosecant of theta, I just flip numerator and denominator here. It's 12 over 5. Cosine is going to be the adjacent side, which is radical 119 over the hypotenuse, which is 12. Tangent is going to be opposite, which is 5, over adjacent, which is square root of 119. And typically we would rationalize that. So 5 radical 119 over 119. And then we would flip this guy to get the secant. So 12 over radical 119, which again, I'm going to end up rationalizing it. So it ends up looking like this. Then take my original tangent and flip it to get the cotangent. So that's going to be radical 119 over 5. So Pythagorean theorem to find the third side, and then you can just use your SOHCAHTOA. All right, example 2 here. I should have drawn a right angle in this one. Find the value of each variable using only the information in the diagram. So that means that I'm not going to use x to find y or x to find z. I'm going to use only what I see in the diagram. So these are going to be solving equations using our trig. So for these ones, you're going to need a scientific calculator. So you can use a handheld if you have it, or you can open a Desmos tab on your device. So it doesn't matter which variable I want to choose to solve for first. I'm going to go ahead and just do them in alphabetical order. So I'm going to solve for x first. So what I know is that this angle is 61 degrees. this is a 90-degree angle, and this length is 41. So based on the 61-degree angle, because you always use the acute angles when we're solving, the x is the opposite side. It's a cross. So the side that I know is the adjacent side. So opposite and adjacent means I need to use tangent. When we're solving an equation that uses our calculator, and we get a clue that we need to do that because it says round to 2 decimal places, we're always going to use sine, cosine, or tangent, not the reciprocals. So I know that since it uses opposite and adjacent, that tangent of 61 degrees is equal to x, opposite, over 41 adjacent. So if I want to solve for x, I would multiply both sides by 41. So in my calculator, I'm going to do 41 times the tangent of 61 degrees. Now, very, very important, especially on a graphing calculator, that you know what mode your calculator is in, because there's degrees and radians. And right now, my calculator is in radian mode, but my angles are in degrees. So I need to change it to degree mode. And then I can go ahead and do my problem. So 41 times tangent of 61 degrees gives me 73.96. It said round to 2 decimal places, so we'll do 73.97. So x is approximately 73.97. All right, now I'm going to solve for y. Again, I do not use x. I'm using only the information given in the diagram. So, similar idea to what I did here, only y is the hypotenuse. So, given side is adjacent, side I want to know is the hypotenuse. Adjacent and hypotenuse is cosine. So this time, I say cosine of 61 degrees equals 41 over y. Now, in my first example, my variable was in the numerator, so I would just multiply to get x alone. Here, I've got my variable in the denominator. Whenever this happens, we do what we called the old Western switcheroo, and we just flip-flop these two values with each other. So y is going to equal 41 divided by the cosine of 61 degrees. So I go to my calculator, 41 divided by, now enclose this in parentheses, cosine 61, and then since it opened a second parentheses, I need 2 sets. And I get 84.57 if I round to 2 decimal places. So 84.57. And these are lengths here. Oops, I wrote x again for some reason. That's why. Okay, last one is z. And in this case, z is the easiest to solve for because you should know that all triangle angle sums add up to 180 degrees. So I know that 61 plus 90 plus z has to equal 180. So do 61 plus 90, which is 151. Subtract that from 180, and I find that z, we forgot what it said, is 29 degrees. And I've solved for all of my variables. All right, last one for this lesson. The Washington Monument is 555 feet high. Find the distance you are standing from the base of the monument if your angle of elevation to the top is 22.8 degrees. So, word problems with angle of elevation. First of all, angle of elevation always starts on the ground. So, when you draw the triangle, you're either going to draw it like this, or you're going to draw it like this, because your theta needs to be on the ground. That's the angle of elevation. So the monument, obviously, because it's an angle of elevation to the top, that means that this is your 555. Now again, it doesn't really matter which way you draw it opening. We are trying to find the distance you're standing from the base. So this is you over here, my lovely stick figure. So this is what we're trying to find. If you're looking at it this way, then this would be your x. Either way, we form a right angle, and we're going to solve it just like we did the things in example 2. So in relationship to my angle of elevation, the 555 is the opposite side. The x is the adjacent, and it doesn't matter if you do it on this side, same thing, opposite, adjacent. So tangent of theta equals opposite over adjacent. Oops, and I forgot to plug in my actual theta. That's silly. It says the angle of elevation is 22.8, so I need to actually put that instead of putting in just theta, so 22.8 degrees. And again, since the variable's on the bottom, that means we're going to do the old Western switcheroo, so x equals 555 divided by the tangent of 22.8 degrees. So in my calculator, 555 divided by, parentheses, tangent 22.8, double close parentheses, enter. And we get 1,320.29 feet. So 1,320.29 feet. I know to use feet because feet was the label here. All right, and that wraps up our intro to trig. Make sure you ask your teacher if you have questions.